Section 8.2, we're going to have trigonometric integrals. So here we're going to have powers on your sines and cosines. So in order to integrate those, you're going to need some trig identities. You're going to need your Pythagorean identities. Sine squared x plus cosine squared x equals 1. This is where we're going to use so we can substitute in a 1 minus cosine squared x for sine squared x, or vice versa. 1 minus sine squared x substituted into cosine squared x. Half or double angle identities, you can't integrate sine squared of x. So we have an identity that converts it back into a cosine of 2x. So there is no power. Same thing with cosine squared x. It's 1 half times 1 plus cosine of 2x. So sine is with the minus, cosine is with the plus. We also have some of our double angle identities, which is just basically these same identities. And all I have done is solved and got the cosine of 2x by itself. So there's two versions of it. Cosine 2 times cosine squared x minus 1. Cosine of 2x equals 1 minus 2 sine squared x. So our strategies, this is, again, you can put this on your note sheet for the test. Your strategies here, if the power of the sine is odd, then factor away one sine factor and save it for the du and convert the remaining factors to cosine. And we'll let u equal cosine of x. So when you take the derivative of cosine of x, you'll get your sine of x, negative sine of x. I had to go check my sheet real quick. If the power of cosine is odd, then you're going to save one of your cosine factors for the du and convert everything into sines. And we'll let u be sine of x, and the derivative of sine of x is cosine of x. That's why you want to convert one of these cosines for du. If both powers are even on sine and cosine, that's where we're going to use our identities up here above. We're going to use our half or double angle identities, whichever one you want to call them. We're going to use these two right here. Okay, so example time. Let's say you're asked to integrate sine cubed of x cosine to the fourth of x dx. So here your sine is raised to an odd power. I am going to take one of those sines and multiply it to my dx. That way I'm now going to let my u be cosine of x, and my du, when I take the derivative of cosine of x, that'll be negative sine of x dx. So I will just take that negative, divide it over to the du, and now I have my substitution here. I need to convert sine squared x into a Pythagorean identity, 1 minus cosine squared of x. That way now I can put my cosine of x can all be u. So we'll put u here, and this will become my du as long as I put my negative out in front of my integral. So there's my substitution. We'll distribute the u to the fourth, and we'll integrate using our power rule. So we'll get u to the fifth over 5, or 1/5 u to the fifth minus u to the seventh over 7, or 1/7 times u to the seventh. Either way you want to write it is fine. Keep your negative out in front. You can distribute it in now, or you can replace your u's with the cosine of x. So distributing in makes this fraction a negative, second fraction is positive. Bringing in your cosine, now it's cosine of x to the fifth power, cosine x to the seventh power, and then don't forget your plus c. Example 2 says integrate cosine of the fifth power of x and sine cubed of x dx. So both sine and cosine have odd powers. We could basically use either one we want. However, go back to the previous problem, and we're going to work smarter, not harder. So here, it would be better to always break down the smaller power, because when you have sine squared of x, I just want to replace it with 1 minus cosine squared of x. I don't want to have to replace, say, sine to the 4th power, because then I got to rewrite it as sine squared of x all squared, and then I have a binomial being squared, and that's just more foiling work. So I'm going to opt to break apart the smallest power, because then I have a sine squared x. I don't have to have a trig to a power, whereas if this was cosine of 4, for the power of 4 of x, I would have to break it down to cosine squared of x, all of that squared, and then put in 1 minus sine squared x, and I'd have to FOIL that. So always go after the smaller odd power whenever possible. Just makes the work easier. That's working smarter, not harder. So we're going to let our u be cosine of x again. Our du will be negative sine of x dx. And again, we'll divide the negative over to the du. And again, sine squared of x, we'll replace that with 1 minus cosine squared of x. And now we make the substitution. U to the 5th times the binomial 1 minus u squared du. But then again, don't forget your negative in front of your integral. Distribute the u to the 5th. Integrate it. We'll have u to the 6th over 6 minus u to the 8th over 8. Distribute the negative and put your cosine of x back in for u's. So negative cosine of x to the 6th power over 6 plus cosine of x to the 8th power over 8 plus c. Example 3, we're going to integrate cosine of x to the 5th power over the square root of sine of x dx. So here, really, you can't work with sine of x because it's inside the square root. So we're going to look at the cosine. It's raised to the 5th power. So we're going to steal a cosine of x, move it to my dx, and we're going to let u be sine of x. The derivative of sine of x is cosine of x. So when I separate it, there's my cosine squared. So notice I didn't write it as cosine to the 4th power. You got to break it down the power to a squared, either to raise to the power of 2. If it was a 6, then it's to the 3rd power. My sine, okay, raised it to the 1/2 power because it's a square root, moved it up to the top, makes it a negative exponent. So here we'll change this to 1 minus sine squared x, all that squared. Don't FOIL it now. Wait until you put the u's in so there's less to write. So here I will have u to the negative 1/2 power, 1 minus u squared squared du. So now I'll FOIL that out. That's 1 minus 2u squared plus u to the 4th. Distribute the u to the negative 1/2 to all these. So you'll just take negative 1/2 and add it to the 2 and the 4, make more fractional powers. So we'll integrate u to the negative 1/2 minus 2u to the 3/2 plus u to the 7/2 du. So here, add 1, power rule, that'll be u to the 1/2, but you divide by 1/2, which is the same as multiplying by the reciprocal, which is 2. Minus 2, that'll be u to the 5/2. Dividing by 5/2 is the same as multiplying by the reciprocal 2/5. U to the 9/2. Dividing by 9/2 is the same as multiplying by the reciprocal 2/9. Then we'll crunch the coefficients here. We'll call that 4/5. We'll bring our sine of x back in for all our u's. And there's my final answer. Rewriting this back as 2 times the square root of x, that's optional. I would just leave well enough alone. Example 4, here sine and cosine are both raised to an even power. Whoops, go back this way. So we're going to have to use our half angle identities. You want to make sure you have those around because you're going to use them quite a bit when you got to do a double substitution like this. So we're going to put in blue 1/2 times 1 minus cosine of 2x in for sine squared x, and 1/2 times 1 plus cosine of 2x in for cosine of squared x. Now, take a close look at what's happening here. We're multiplying this all together, so 1/2 times 1/2, that's going to be 1/4. We're going to move that out front. Then I'm going to multiply these two binomials together, which happen to be a conjugate pair. That's going to give me 1 minus cosine squared of 2x. Well, wait a minute. That's a Pythagorean identity. You cannot integrate cosine squared. So let's change this to sine squared of 2x. I know you can't integrate that either. So let's bring the 1/2 times 1 minus cosine of 2x back down here. Now you got to remember, this 2x right here is technically just this x. So that's x being doubled to 2x. So now 2x will be doubled to 4x when I rewrite it. Take the 1/2, factor it out front, we'll call that 1/8. Integrate the 1, that's an x. Minus integrate cosine of 4x, that's sine of 4x. But don't forget, you have to take the derivative of the inside, which is 4, and divide it into your sine of 4x, or multiply it by 1/4, whichever you prefer. Distribute the 1/8, we'll have 1/8 x minus 1 over 32 sine of 4x plus c. All right, example 5. Let's integrate x squared sine squared x dx. At first, this looks like it would be an integration by parts, but because it's sine squared, we can't do integration by parts. So again, we'll use our half angle identity. So sine squared of x equals 1/2 times 1 minus cosine 2x. We'll make that substitution. Again, we'll factor the 1/2 to the front of the integral. And let's distribute in the x squared into our parentheses. So now what we'll do is we'll rewrite this as two separate integrals. So this will be 1/2 times the integral of x squared dx. That will be just a simple power rule. But now minus the integral x squared cosine 2x dx. That is going to be an integration by parts. So let's integrate this part. There's my x cubed over 3. And this is my integration by parts that you're either going to do twice because of the x squared, or if you want to do that tabular integration, we can do that. So make your table over to the side. Dx, that's going to be your x squared, because that's my u. Remember, u is always under the dx. And your cosine of 2x dx, that's your dv. That's under your integral, and that's what we're going to integrate. So we'll take the derivative of x squared is 2x, then the derivative of 2x is 2, and the derivative of 2 is 0. Always go 2, get to a 0. We integrate cosine of 2x, that's going to be sine of 2x. But again, taking the derivative of the inside 2x, that's 2 that we want to divide to sine of 2x, or multiply by half. Integrate it again, that'll be negative cosine of 2x. But again, the derivative of the 2x is going to be 1/2, or excuse me, 2. We want to divide by 2, or multiply 1/2 to your 1/2 to get a negative 1/4. Taking the integral of cosine of 2x, that's sine of 2x, but again, you have to take the derivative of 2x, which means you divide by 2, which is, or multiply by 1/2, we get to negative 1a sine of 2x. All right, so remember, signs positive, negative, downhill products. Okay, those are the three things I have to multiply. So I'm going to have 1/2 bracket x to the third over 3 minus, okay, parentheses, x squared times 1/2, x squared over 2 sine of 2x. A negative times a negative is a positive, 2x over 4, or reduce it to x over 2 cosine of 2x. 2 times negative 1/8 is going to be a negative 1/4 sine of 2x plus c. We're going to distribute in the minus sign, which is going to change all the signs, and I'm going to distribute in the 1/2 to everybody. So 1/2 times my x to the third is x to the third over 6. 1/2 times x squared over 2 becomes x squared over 4, but also distributing the negative changes the sign. The plus becomes a minus with distributing the sign. X over 2 becomes x over 4. The minus becomes a plus. 1/4 times 1/2 is 1/8 times sine of 2x plus c.